And though it may sound surprising, the best way to stay protected before, during, and after a nuclear detonation is getting inside. Similar to protecting yourself from tornadoes or hurricanes, getting and staying inside a sturdy building would offer protection from the explosion's shockwave, heat, and radiation. The shockwave of energy would travel several kilometers beyond the fireball's radius in the first few seconds. Sturdy buildings within that range should be able to withstand the shockwave, and staying in the centers and basements of these buildings also helps provide protection from heat and flying objects. Finding shelter is especially important if the fireball occurs close to the earth, as it will pull thousands of tons of dirt and debris several kilometers into the atmosphere. As the fireball cools, unstable atoms created by the nuclear fission mix with the debris to produce the most dangerous long-term effect of a nuclear detonation: radioactive particles called fallout. These sand-sized particles emit ionizing radiation, capable of separating electrons from molecules and atoms. Exposure to massive amounts of this radiation can result in cell damage, radiation burns, radiation sickness, cancer, and even death. Thankfully, the same buildings that offer protection from the blast are even better at guarding against fallout. Radiation is reduced as it travels through space and mass. So while a broken window and sealed window both have the same minimal effect on radiation, thick layers of steel, concrete, and packed earth can offer serious protection. Well, today I'm going to tell you about a serious reality that is changing our oceans called ocean acidification, or the evil twin of climate change. Did you know that the oceans have absorbed 25% of all of the carbon dioxide that we have emitted to the atmosphere? Now, this is just another great service provided by the oceans, since carbon dioxide is one of the greenhouse gases that's causing climate change. But as we keep pumping more and more and more carbon dioxide into the atmosphere, more is dissolving into the oceans. And this is what's changing our ocean chemistry. When carbon dioxide dissolves in seawater, it undergoes a number of chemical reactions. Now, lucky for you, I don't have time to get into the details of the chemistry for today. But I'll tell you, as more carbon dioxide enters the ocean, the seawater pH goes down. And this basically means that there is an increase in ocean acidity. And this whole process is called ocean acidification. And it's happening alongside climate change. Scientists have been monitoring ocean acidification for over 2 decades. This figure is an important time series in Hawaii, and the top line shows steadily increasing concentrations of carbon dioxide or CO2 gas in the atmosphere. And this is directly as a result of human activities. The line underneath shows the increasing concentrations of carbon dioxide that is dissolved in the surface of the ocean, which you can see is increasing at the same rate as carbon dioxide in the atmosphere since measurements began. The line on the bottom then shows the change in chemistry. As more carbon dioxide has entered the ocean, the seawater pH has gone down, which basically means there has been an increase in ocean acidity. Most people intuitively blame it on their nerves. But why does being nervous undermine expert performance? There are two sets of theories, which both say that primarily choking under pressure boils down to focus. First, there are the distraction theories. These suggest that performance suffers when the mind is preoccupied with worries, doubts, or fears, instead of focusing its attention on performing the task at hand. When relevant and irrelevant thoughts compete for the same attention, something has to give. The brain can only process so much information at once. Tasks that challenge working memory, the mental scratch pad we use to temporarily store phone numbers and grocery lists, are especially vulnerable to pressure. In a 2004 study, a group of university students were asked to perform math problems, some easy, others more complex and memory intensive. Half the students completed both problem types with nothing at stake, while the others completed them when calm and under pressure. While everyone did well on the easy problems, those who were stressed performed worse on the more difficult, memory-intensive tasks. Explicit monitoring theories make up the second group of explanations for choking under pressure. They're concerned with how pressure can cause people to overanalyze the task at hand. Here, the logic goes that once a skill becomes automatic, thinking about its precise mechanics interferes with your ability to do it. Tasks we do unconsciously seem to be most vulnerable to this kind of choking. So, my optimism is rooted in the fact that for almost 200 years, every year has gotten a little bit better when we look at the scientific evidence. And while it's possible that next year everything could change, that everything could collapse and fall to the ground, statistically, probabilistically, it won't. It will continue because 200 years has gone, and next year it probably will continue. But if you look at the kind of current political regime around the world and the factors of pressures, environmental pressures, the pressures of distraction that we have from the new media, then I think you have to resort to hope. In the long term, optimists decide the future. It's the optimists who create all the things that are going to be most important in our lives, because it was optimists who built and invented all the things that are now important in our current lives. And I think people behave better when they're optimistic. There's absolutely a need to be critical and doubtful and skeptical and even pessimistic. Just like if you have a car, you have to have brakes. You can't have a car no matter where it is without brakes. But it's the engine, the optimistic engine, that keeps going and refuses to stop and is only concerned about going forward. That really drives a car. You could put a Trader Joe's or Walmart on every corner, and food insecurity could still not afford to eat or to buy what they should be eating. Why? Because America's food system is designed from the Farm Bill on up to make calories cheap and nutrition expensive. That's why the face of hunger in America today is an obese person. Food insecure Americans are forced to fill up on food that's loaded with sugar, fat, sodium, and little nutrition. Hence, the answer isn't a full stomach, it's a healthy meal. So, my next learning was about money. Nonprofits tend to spend 75% of management's time on fundraising. They do great work. It's the air they breathe. But funder fatigue sets in, funding dries up. So I wondered, instead of seeking donors to continually fund our mission, year after year, would it be possible to have a mission that could fund itself? Well, we did something interesting. We actually went into a food insecure neighborhood and asked the people what they wanted. And they said, "We don't want handouts. We want to buy tasty, nutritious food we can afford. We're not looking for charity. We're buying food now. We want to keep buying food. Don't make your store needs-based. Everybody should be able to shop there. We don't want to feel stigmatized by shopping in a store that's just for poor people." Another light bulb. Turns out people are even hungrier to keep their dignity than for nutrition, which means we can use the dignity problem to help solve the funding problem.
If you did, please give this video a thumbs up and subscribe to the channel for more PTE-related content. Don't forget to leave a comment below letting you know what you think or if you have any questions. Thanks for watching. I will meet you soon at our next video.